Hello, welcome to this Vintage APL episode on IBM PC APL 1.00 for IBM personal computers. My name is Jamie. This version of APL was released in 1983 by IBM. In this video, I will give an overview and demonstration of APL 1 for the PC. Let's get started. I'll be using the implementation hosted on the PCJS IBM PC Emulator website. A link will be found in the description below. First, before we jump into the specifics of IBM PC APL, I want to use the APL Wiki to orient you on where this version of APL falls in the timeline of influential array languages. So IBM released APL 360, not necessarily released, but IBM produced APL 360. It was completed in 1966. They made a version of it that ran on the 1130 mini computer in 1968. Just focusing on IBM in the timeline here, 1973, IBM released APL SV, which includes shared variables. And then 1976, VS APL was released, which allowed APL to interact with the host system. This was specifically, I believe, for the VM systems. Now, PC APL is not listed here in 1983, but I want to point out in 1984, IBM produced APL 2, which was built around nested arrays. All of the IBM APLs before then had been built around flat arrays, and that does include IBM PC APL version 1. Subsequent to 1984, IBM did release APL 2 for the PC as well. All right, so let's jump over to the emulator website. There is a link to the documentation. It is a 300 plus page manual that's very thorough and complete in IBM fashion for this version of APL PC version 1.00. And so we'll take a look at the documentation before we come back and do a demonstration here in this emulated environment. The documentation is a PDF file. It is titled simply just APL by the IBM Madrid Scientific Center. And if we look at the copyright information, this is the first edition from 1983. Let me jump forward to the preface. This gives an outline of what you'll find in the manual. It has two parts, the first 4 chapters followed by the next 8 chapters broken up into part 1 and 2. So we have the operation guide followed by the APL reference guide, and then there's some appendices at the end. So we have an introduction in chapter 1, a description of some provided IBM PC application workspaces, which, as described here, will help you with operations like printer management, full screen editing of APL definitions, DOS file management, asynchronous communications with IBM System 370 hosts, and music. Chapter 3 describes auxiliary processors, which can let you add extra functionality to this version of APL. There are some built-in auxiliary processors for graphics printer control, BIOS and DOS interrupt handling, full screen display management, DOS file management, asynchronous communications, and the music generator. You can build your own auxiliary processors by writing some assembly code and adding is essentially adding your own features to APL through this mechanism. And then starting in chapter 5, we have a description of well, not only the description, but the user manual for this version of APL. So it is, in essence, the same APL that you would find on IBM mainframe circa 1983 with these extra features that you can include built in. Just pointing out a couple chapters here. We have chapters 8 and 9, which include system functions, system variables, and shared variables. Chapter 12 has the system commands that are used to control work sessions and manage workspaces and so on. So let me move forward to the command line documentation, which is on page 33. So from the command line, we will be able to include, we'll run APL, and then we'll be able to include these extra features. EX-APL is like an auxiliary processor, basically. It adds more functionality to formatting. And so we have a dyadic version of formatting that lets us have numeric formats and picture formats for output. And then we have the AP files, the auxiliary processors, which can be included. You can include none of those or some or all of those. And then there's the option to run a specific APL system command at the end of the command line. And so that's all described here. And you can see, again, those processor numbers here. In this video, I'm not going to go into the depths of using the full screen display management facility or specific DOS file management, but those are there. And so if you want, for example, to read data in from files or to write data from APL out to DOS files, you would find that described in the section that talks about AP210, for example. And then it mentions here about the APL system command. You can read more about that in chapter 12. Let me just quickly go back to the operation guide just to show you the system requirements for this machine back in 1983, or for running IBM PC APL on the machine back at that time. So this includes some, again, these are more description of the specific PC facilities, and then the workspace facility, the data, floating point, integer, character, and Boolean. The math coprocessor is required for this. And then we get down to the requirements. The minimum requirements were the original IBM PC or PC XT, at least 128K of RAM, the PC math coprocessor, at least one diskette drive, CGA graphics, and then there were some optional features there as well. Okay, I'm going to move up to page 41, which will show us the keyboard layout. So in APL 360, there were several characters that needed to be created by overstriking. And you can see that some of those here on the front of these, the keycaps up here on the number row. In this version, these are available on the keyboard directly. We don't need to use overstrike. So typically, to get just a normal character, you just type the character you see on the front of the keycaps at the bottom. To get the shifted character, the ones you see at the top, you would hold down the shift key. For these characters that are on the front of the keycaps, you access those by pressing the Alt key in addition to the number keys that are there as well. And you'll see there are some other overstrike characters down here to the left of the Z. Now on our modern keyboards, we don't have a key. On my keyboard, what's to the left of the Z is the shift key. So you may have to hunt around on your keyboard to see where these specific keys have been moved. I believe this one to the left of the Z is the uh, backtick and tilde key, which you might find on the top row of your keyboard to the left of the 1. So I have on my keyboard, my escape key is up on the function key row, and then I have a backtick tilde key that's in place of the escape key, and so I believe that that's takes care of this key to the left of the Z, and so on. All right, so let's go to the emulator now. Let me see if I can make this full screen. Okay, there we go. So when you first load this web page, it will boot up an emulated IBM PC. It'll read DOS from drive A and then switch over to drive B, where IBM PC APL 1 is installed, and then do a directory of that. So this is basically where you will start. So how do we run APL from the DOS prompt here? We do APL, and then we include the extra facilities that we want. And so my go-to ones are EXAPL for the picture formatting, and AP205, and AP210. So upon running, we get IBM Personal Computer APL version 1.00, copyright IBM 1983, produced by IBM Madrid Scientific Center, and we starting with a clear workspace. So, I'm not going to go into a tutorial of APL here, but everything should work as you would expect. So we can do our calculations. We can access those the keys using the built-in operations using the shift key, or we can get let's do a matrix here. M gets 3, 3, reshape iota 9. Okay, and let's say that we want to transpose that. So I believe that is Alt 6 will give me the transpose symbol, transpose M. And so there we see a transpose of our matrix. And again, to access that, the circle with the backslash through it, we didn't type that in as 2 separate characters. It was just by pressing the Alt key on the keyboard and accessing that. We can, again, there's a lot of things I could demonstrate here. The numbers 1 through 10, we could add those together. We can multiply them together to get a factorial of 10 and so on. Let's write a quick hello world function. So I'm going to define hello, and we'll just have it print out hello world. So backspace works. We don't do a separate line feed like we did in APL 360. So it makes editing much nicer in this system. So there's hello world, and we'll run hello to see hello world. Okay, I'm going to save this as a workspace. I'll call it hello. Now to see your workspaces, we'll do a paren lib. This basically just does a dir on the drive that you're currently operating from. And so at the bottom, I see there is a hello APL workspace there. Now I can clear my current workspace, and we'll see hello's not defined now. So we'll load in the hello workspace. We can see what functions are available, and we can see what variables are available. And so those are back available again. Now, the workspace is saved to this drive image for the B drive, but if we were to reload this emulator website, that image would go away completely, and we would be back starting with the original IBM PC APL image. So if you want to save your work to your own local machine, you can do that. There's a very nice facility built in here. I'm going to switch over to the B drive, and it tells me what originally was loaded. Now, if I want to just reload and get rid of everything that I had saved on the image previously, I could just click load and it would load a fresh copy. But I want to save this, so I'm going to click save. It will put this in your downloads folder. I have downloaded a few of these already, so it'll give it a specified name here, apl-100.img, and then your web browser will add extra numbers to that if it needs to. I'll keep that. Check your downloads folder for the image. Click OK. All right, so that image has been saved. I can now go away from the website, close my web browser, go back to the web browser later. Let me just do a refresh. So you'll see the emulated PC booting up, and it'll load DOS off of disk A and set the current date and time, and then do a directory, go to the B drive and do a directory of the B drive. Okay, so I'm here at a fresh version of fresh APL installation. I want to load my image. Okay, so I've put my image in a separate folder just so you don't have to see my messy downloads folder. So here's the image, apl-100.img. Now you can name these images after they've been saved. You can rename them. So if I want, maybe I have a specific image for my finances, and I just call that finance.img. And maybe I have a separate image for games, and I call that games.img. So you can load different floppy drive images depending on whatever you want to store on them. So I'm just going to click here and do open. Now that image is ready to be attached. It's attached, but it's not active. So I guess we'll use the term mount whenever you've attached it, but then you want it to become active. You're going to mount the image. So it's kind of a two-step process here. So I've chosen the file. Again, I did a dir. It's not active yet, so I need to click mount to make it active. Now I think let me refresh this. I'm not sure if I had this switch from A to B. It looks like A is now set to the local disk, which is not what I want. I want B to be the local disk. So let me refresh. Okay, so here I'll choose file again. Oh, before I do that, I need to switch from A to B because I want DOS still available on drive A in case I need some features there. So I'm going to switch over to B. Then I'm going to choose file, choose my APL image, and then choose mount. So now if I do a dir, we'll see at the bottom is that hello workspace. So in the DOS directory, I can see that the file name has been padded with some underscores afterwards. There are other workspaces, so these are the workspaces that are mentioned in the manual up here at the top. We have File, Music, Print, VM232, and Edit. But these AIO files are also workspaces as well. They just don't show up when you look at your own library of workspaces. So we've mounted it. I can see now the hello workspace is there. So we could do run APL from the command line. Now we can load hello. We can see our functions. We can see our variables. And in this particular version of the workspace, I didn't have the matrix M saved. So I only have the hello function. And we can run the hello world program, and that works just great. So this is a great quick easy implementation of APL that's full featured that you can run from a web browser, so I find it really useful and handy when I just want to just do something fun in APL, just uh, boot up something on just any computer wherever I am. I just open up the web browser. It could be a Chromebook, a Mac, Linux computer, Windows computer. Um, it's just runs from the web page. The limitations that I've ran into are mainly around printing. I don't think there is a way to connect this emulated PC to the printers that are installed on my system. So when I have data that or items that I want printed out, I basically will just take some screenshots. I'll use the snipping tool, for example, and just snip the screen and paste that into a separate document, and then I produce my printouts that way. But I hope that you have enjoyed just this tour, even if you don't end up using IBM PC APL. There are, you know, better APLs out there if you want to run a standalone APL on your own machine. But if you're on a machine like a Chromebook where you can't necessarily install APL, maybe micro APL or dialog APL or something on that, this web page is a great opportunity to play around with and get exposed to a great vintage APL system. I appreciate you watching, and I hope to produce more of these videos over other vintage APL systems in the future.